Hey physicist, what's the crack? So today what we're doing is we're going to figure out what is the horizontal distance traveled by this projectile if it's launched like this in the diagram. Okay, so again, the first thing I would do is I set up my SUVATs, okay, because I know that the vertical motion must be independent for its horizontal motion, okay. So again, set my SUVATs in the vertical direction. I have U, V, S, A, T. And in the horizontal direction, I have speed, distance, and time, okay? And again, I can use speed equals distance over time for the horizontal direction because in these questions, we always assume that there's no air resistance, okay? So there's no forces opposing the motion, okay? So again, so in the vertical direction, I need to find out what the initial speed is, okay? What I have is a speed at an angle of 30.2 degrees above the horizontal. So I need to figure out what is that vertical speed and what is the horizontal speed to begin with. So again, what I do, like we've done before, is that if you take your force or your speed and you go through the angle, that's always a cosine. So this one is going to be 59 cosine 30.2. And again, if I take my angle and I go in the opposite direction, I did not go through the angle, I committed a sin, which is why I went against the angle. So it's going to be 59 sine of 30.2. Okay, so now I just want to put those numbers into my vertical and horizontal speeds. So for the vertical speed, I'm typing in 59 multiplied by the sine of 30.2, and we get initial speed of 29.68, which makes sense because it's a positive direction. And then to find my horizontal speed to begin with, I type in 59 multiplied by cosine of 30.2, which gives me a horizontal speed of 50.99 meters per second. Okay? So the whole point was to find the horizontal distance traveled. Okay? So I know, again, for horizontal directions, I'm going to use speed is distance divided by time. So in order to find the distance, what I do is speed times time. So if I'm trying to find the distance, I must know these two values already. Okay? So I must know time, and the only way for me to find out time then is to go to my vertical motion, and whatever time I get for the vertical motion must be the same as the time for the horizontal motion because it's just one object, right? Okay, so then I go back to my vertical, and the whole point here is I'm trying to figure out what that time is. So I see what other SUVATs do I have. So I can see that it drops 125 meters. So the distance it drops is minus 125 because, again, downwards is going to be our negative direction. Okay, so it drops 125. I know the only force acting on it is the downward force due to gravity. So because it's a downwards, it's negative 9.81. So I look at my SUVATs and I see I must have enough information to calculate T. So I look for my SUVATs on my data sheet, and the only one that makes sense then is going to be S equals UT plus a half of AT squared. Okay, so what I have then is I fill in my numbers. S is minus 125 equals UT, so 29.68 times by T, plus a half of negative 9.81 times by T squared. So we look at this, the first thing you should see, if I've got a T and a T squared, okay, I've got a quadratic formula. Okay, so the only way to solve this is to use the quadratic formula. So the quadratic formula for my math classes is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And the way to solve this is because we have an equation in the form ax squared plus bx plus c. So I want to figure out what these numbers are that I insert into my quadratic formula. So we need to rearrange this equation to have it presented in this form. Okay? So what I have here, I'm going to simplify negative 9.81 times a half. So 9.81 divided by 2 gives me an answer of 4.905, but it's a negative number. So what I do, if I take a negative over the equals, over the magic bridge, it becomes a positive. So what I have is 4.905 times by t squared. Again, I'm going to take over this over the magic bridge. So it was positive, it now becomes negative. Take away 29.68 and I've got a negative 125. So what I can see here is that my A is 4.905. My B is negative 29.68. And my C is negative 125. So that's the data, or the values, that I pop into my quadratic equation. Okay, so what we're doing again is negative B. So I'm going to use the negative of a negative. I'm going to use 29.68 plus or minus negative 29.68 squared minus 4 times A times C, and then square root of that, divide it by 2 times A. And when you do that, we're not actually solving for x because it's t in my equation. You're going to get two values for t. You get two values of t. You're going to get a positive number of 8.91 seconds, and you're going to get a negative number of 2.86 seconds. Okay, so clearly the only number that makes sense would be the positive number because I can't get negative time. So I've just solved for time, and I got 8.91 seconds. So I put my number in, 8.91 seconds. Again, we know the time is the same, so the time here is also 8.91 seconds. So now I can just plug that number into my final equation. So the distance is going to be equal to 50.99 multiplied by 8.91 to get a final answer of 454.3 meters.